Yesterday I uploaded a video about an iPhone 8 Plus that does not power on. We went over the board and we came to a conclusion that the problem is the PMIC chip. We used a thermal camera along with an atomizer, and we noted how Flux was burning at the very edge of the PMIC chip. And I said that we're gonna have to communicate with the customer to let him know what's going on, and we're gonna have to get the okay from him before we move forward with the repair. This morning I was going over the comments and few people commented and said I should check the 3-volt line, the Nand line, the 3-volt Nand line. So I asked Big Boss to take the phone apart, and I went to check the Nand line, and it's true that we have a short circuit on the 3-volt Nand line. Let me show you what's going on. So the first thing I did this morning before I pushed on the record button was I scraped that overfill from over the component. This is the 3-volt Nand line right here, ground, and 3 volts here, and I measured. We had a short circuit. So that's the problem. I missed it in yesterday's video, even though I worked on it before. I worked on that very same problem before, and I have more than a couple of videos on this very same issue, but I missed it. If you look here, we had heat on this edge, on this side of the PMIC chip, right? So any one of those pins could be causing the short. Now, if we look at the 3-volt Nand line on the right here, you will see that the Nand line is made out of this capacitor here, this capacitor here, this capacitor all the way on the left, this one all the way on the left, and several caps on the top. And those caps are connected with several points on the NAND chip. So we're gonna have to check 1, 2, 3, 4, 5, 6, 7, 8. Probably 8 components we need to check to see if we have a short. A short that generates that much heat, like what we saw yesterday. The board was generating about 210 degrees Fahrenheit, and that's measuring from over the shield. So the component itself was beyond 210 degrees Fahrenheit. A small capacitor is not gonna cause all that heat. So right now I'm gonna focus on the big caps. The cap on the far right, which is very common to fail, and I've worked on it many times before. A component, a big cap on the left, and we have a big cap on the top here. We're gonna start with the one on the left, on the right. And right now I already scraped off the overfill from over that component so we can expose the test points. And we're gonna measure meter in diode mode. And we're gonna do this. We're gonna measure from ground to here. You see? If we go to ohms mode, I'm getting 0 ohm, and on this side 0.1 ohm. So it's a dead short. The error margin of the meter 0.1 or 0.2 or 0.3. We have a dead short. We're gonna start with this one. I already scraped the overfill. I'm gonna inject voltage 1.2 volts on the left side of the component, because the right side is ground, and we're gonna monitor the board under a thermal camera and see what gets hot. So that's the NAND chip right here, and we have a cap on the far right, one on the far left, and one on top. I want to see which one of those caps is the one that is shortened to ground. We're gonna start with the one on the right. I'm gonna inject voltage on the left side of the capacitor. Look at this. It's the one on the right that is getting hot, not the one on the left and not the one on the top. What if we look at our PMIC chip? We do not see any heat on our PMIC chip because I'm injecting voltage directly at the component that is shortened to ground, and that's why that component is heating up. Look at this. I just want to mention some of the people who brought this to my attention. Mo AK, a longtime follower of the channel, and we have some of those usernames I cannot even spell. Pontius Edits and Smartphone Expertin, and we have Recur Belgi. Thank you very much. I think that's what the problem is. Let's go ahead and remove the cap, and we're gonna attempt to power that phone on and see if that fixes the problem. And we're gonna also measure for a short again after removing that cap to confirm that we got rid of the short. Just a little bit of heat, and we're gonna remove it the old-fashioned way. And done. Let's see, do we still have a short? Do we still have a short? How many times have you heard me say short on this channel? $1 million prize to anybody that figures out how many times I said short on this channel. $1 million in Monopoly money. Just go through all the videos, all 800 videos, and count how many times I said short on this channel. We're gonna measure using diode mode, and before we had a short here, and right now we are no longer getting a short. Done. Done. Fixed. That's it. Let's go ahead and reassemble the board so we can test. I'm gonna connect the charging Flux, the battery, and the screen. I do not need to connect anything else. We just want the phone to turn on, and the customer needs data. Why would anybody care about an iPhone 8 Plus? You can buy a used one for less than what it would cost to get this fixed. Okay, so I connected the battery, the charging Flux, and the screen. We do not need to connect anything else. And let's plug the charging cable and see. Will that fix the problem? 0.1, 0.2, great. It's not jumping to 0.6, and I see the battery logo right there. Phone is working. The phone is working. So the problem is the 3-volt Nand line. Battery charged up, and the phone is on. The phone is on. Okay, we have a customer. Just a minute. I'll be back. Bye. Take care. So the phone is working. Okay, the phone is working. And of course, touch is working, and that's what the customer needs. He want to be able to back up his data. So that's it. We're going to end the video right here. I hope you enjoyed it. Happy ending. Let me know what you think. Don't forget to like and subscribe, and we'll do something else in the next video.